Hi everybody, I am Deepu and I welcome you all to Fundamental Physics by Master Deepu. Good morning first of all to all my viewers. Friends, in 2019 I started making small videos of 11th 12th content and started putting it on YouTube because at that time I was getting some time. I was doing graduation also, and I think that's the beginning of pandemic, so I was having some time, so I decided to just go through those lectures and try to put those contents on YouTube. But after that I got engaged in my own study. I just started preparing for general competition examinations, and now I am placed in Bihar Police as a sub inspector. So I am wondering here and there for physics optional material because still I am trying to go a level above from it through BPSC, and in BPSC I have decided that I have chosen that I'll opt physics as my optional. So I was searching here and there. I was just looking for the material here and there, but I was not getting material systematic anywhere. So what I have decided that I'll collect the materials. I'll simply cover the topics from different sources, and then I will just collect them and put it on YouTube, so that in a way I would be able to help all those who are looking like me, wondering here and there for the systematic content of BPSC Physics optional. So in that particular run, today I'll simply start with I'll put the first lecture on YouTube today of the BPSC Physics optional. The first section is of the classical mechanics, and among it the first topic is the conservation law. So today we are going to do the conservation theorem for the individual particle. For a single particle we will do the conservation law, and it will include conservation of momentum, linear momentum I mean, and then the conservation of angular momentum theorem, and then the conservation of energy theorem. So let's start the video, and be with me throughout the video, and if I'll commit any mistake then apologize me. So gentlemen, let's start. I have stated a bit earlier that it's a mechanics of particle under classical mechanics topic, and we are going to deal with conservation law, and it will include what? Conservation of linear momentum first. The A part means it includes the three subparts, and the B part is the conservation of angular momentum, and the C part is the conservation of energy. So let's start with the first part first, that is the conservation of linear momentum. So friends, we'll just discuss about it. Let's first discuss about the conservation of linear momentum. If force F is acting on a particle of mass m, then according to Newton's second law of motion, we have force dp by dt. Here p is the momentum, and we can write d by dt. P can be replaced by mb because mb is the linear momentum. I have already mentioned it here, where p equals to mb is the linear momentum of the particle. If the external force acting on the particle is 0, then dp by dt, d by dt, again p is replaced by mb, equals to 0, because force, we are assuming that the force, external force is 0, then only conservation theorems can be validated. So we replace the force, this force, as 0 here, and again write the same equations, sub part here. Dp by dt equals to d by dt mb. This equation simply shows that the derivative of mb is 0. It means mb is constant, because the derivative of constant is 0 in what we say in what we say differentiation. Only the derivative of constant function is 0. Here d by dt of mb is 0. It means mb is constant, so we write p equals to mb equals to constant. Hence it shows that when external forces acting on a particle is 0, then its linear momentum remains conserved. So the first part of the conservation law, that is the conservation of linear momentum, gets verified here. Now we'll start the second part, that is the conservation of angular momentum. So friends, be with me, and if I'll commit any mistake then apologize me. Now the second part, that is the uh, conservation of angular momentum theorem. We will go with the angular momentum of a particle p of mass m about a point O is defined as, let's just think, this is the point O, and about it we have to find the angular momentum of this particle p, and this particle p, we have to find the angular momentum, and this p is what? This p is the momentum of this particle. So vectorically we can write angular momentum can be represented by j vector. J vector equals to r vector cross of p vector. R vector is the position vector of this particle, and p vector is the momentum of this particle, small particle. Already I have stated, and I have also mentioned it here. If the force on the particle is F, let's just think that this particle P bears a force of F, then the moment of force or the torque, moment of force can also be stated as torque about O is given by, if force acting on this particle is F and position vector is R, then the torque of this particle along this point O can be written as tau vector equals to r vector, that is the position vector cross product of force. R cross F is the torque. Now if we differentiate this above equation, that is j vector equals to r vector cross p vector, if we differentiate with respect to t, then what we will get? Dj by dt equals to d by dt r cross p, and further dj by dt dr by dt cross p plus r cross dp by dt. We can write it because it's just a simple, what we say, mathematics here. Dj by dt equals to, again, dr by dt can be written as v, that is the velocity. Position vector, derivative of position vector with respect to time is velocity. Again, p can be replaced by mv, that is mass into velocity. So v cross mv, the direction of this velocity vector and this velocity vector, because mass is constant here, is the same, so angle between them is 0, and we know that a cross b equals to mod a mod b sine of theta. So mod v mod of mb sine of theta, theta here is 0, so this whole term will vanish, this whole term will become 0, or r cross dp by dt as it is, we have written it down. So in the next step, dj by dt equals to r cross f, because this term already has vanished. I have stated the reason why this term has vanished. So gentlemen, dj by dt will become r, again dp by dt can be replaced by f. Dp by dt, that is the rate of change of momentum, and that is equal to force. So dj by dt will be equals to r cross f. Therefore we can write, and r cross f is tau also. Here from this equation A, we know that r cross f is tau, and here we have found out that the rate of change of angular momentum with time is r cross f. So we can write tau equals to rate of change of angular momentum equals to r cross f, or d by dt r cross p, d by dt r cross p, because this is equal to what? We have replaced j with r cross p, means derivative of j, and j can be replaced by r cross p. From the above equation, it is clear that torque acting on a particle is equal to rate of change of angular momentum of particle. That's very simple here. Here we have mentioned that torque equals to rate of change of angular momentum, So for the conservation of angular momentum, there is an assumption that the torque on the system, the net external torque or the moment of force on a system is 0. So if this term is 0, if we make torque 0, then derivative of r cross p, that is j vector, angular momentum is 0, and hence angular momentum is conserved, angular momentum is constant, because the derivative of constant function is 0. So from here we have stated that the derivative of constant function is 0, and here the constant function is j, that is the angular momentum, hence the angular momentum is constant. Now the third part of our discussion is conservation of energy of a particle. Energy, we have to in the previous two sections we had deal about the linear momentum and the angular momentum. Now we have to go through the energy of the particle. So let's first define the work done. Work done by an external force F acting on a particle in displacing it from position 1 to position 2 is defined as W12 integral of 1 to F dot dr. F is the force and dr is the position vector. Force is that dr is the displacement, small displacement. So according to Newton's second law, we can write F equals to m dv by dt. dv by dt is acceleration. Hence, above equation can also be written as W12 work done from 1 to 2, integral of 1 to 2 f dot dr, and now we replace this dr as dv by dt into dr. This force as m dv by dt, again dr, because force can be written as m dv by dt from above, from Newton's second law. Again, m is constant, so we keep it out of the integral 1 से 2 dv by dt dot v dt. Why we have brought dr as v dt? Because it equals, dr equals to v dt. I have stated here dr equals to dr by dt into dt. We can write now, this dt will cancel with dt and dr will equal, but dr by dt we can write it as v also, so it will, dr can be replaced with v dt. We have did the same here. Work done from 1 to 2 will be equals to, again now this dt will cancel with this dt, and the integral will become very simple, v dv 1 to 2, and we can simply write it v square by 2. So again, multiplying with the constant, we write md square by 2, and its limits are from 1 to 2, so we have put it here. So work done from 1 to 2 is half m v2 square upper limit minus half m v1 square. So in the physics terminology, we represent kinetic energy with capital T, and half mv square is nothing but the kinetic energy. So we can say W12 equals to half m v2 square minus half m v1 square, or W12 equals to T2, that is the kinetic energy at position 2 minus kinetic energy at position 1. So here we have simply bring the work energy theorem, that is the work done goes to change the kinetic energy. Work done from 1 to 2 goes to change the kinetic energy. Now let's discuss about the potential energy, because we have to state that the mechanical energy of the particle is conserved when the forces are conservative in nature. So gentlemen, I'll just want to remind you guys one thing, that spring forces is also conservative in nature. Here I have simply demonstrated a spring attached with a block, and a force F1 is acting on it. So we can write force spring negative of kx. We already have gone through this in 11th-12th. And now the potential energy stored in this spring, either by compression or by expansion, is half kx square. So if we differentiate this expression half kx square with x, then it will become du by dx. U is the potential energy of the spring. Du by dx equals to half k 2 times x, and this 2 will get cancelled with this 2. So du by dx will become kx, and that will be equals to negative of f spring. So from here we write f vector, that is the force, equals to negative of du by dx. Here I have represented potential energy with v, so don't get confused. F equals to negative of derivative of potential energy with position vector. Now cross multiplying, we get f dot ds equals to negative of dv. Now integrating both sides, we get f dot ds limit 1 to 2 equals to negative of 1 to 2 dv, and this will become again dw, and we already have the integral of dw will become w12, and the integral of dv, that is the potential energy, become v2 minus v1 limit, but the here negative sign is there, so it will change the limit and it will become v1 minus v2. Now from above equation, from this equation, first we have got w12 equals to t2 minus t1, and from here equation second, Roman number second, w12 equals to potential energy at position 1 minus potential energy at position 2. Now both these equations are equals to work done from 1 to 2, so if we equate them, what we will get? We will get kinetic energy at position 2 minus kinetic energy at position 1 equals to potential energy at position 1 minus potential energy at position 2. So now just interchanging, we will get potential energy at position 2 plus kinetic energy at position 1 equals to kinetic energy at position 1 plus potential energy at position 1. So it states that mechanical energy at position 2 equals to mechanical energy at position 1. This shows that the energy remains conserved when the forces acting on a particle is conservative in nature. So gentlemen, I have tried my best because I don't have those that much of sources to make you guys very much understandable by just writing it on smartboard and other things. I'm not having that much sources, and neither I do have that much of time to arrange all those things. So whatever effort I can do, I can put, I have put it. So if you guys feel this video as informative, helpful, then do share this channel, like this video, and comment whatever mistakes you feel that I have committed. I will just try to rectify it in the next section. So thank you very much.